And action! Hey, we're going live here. Fourth period is joining me on this video because I don't want to make one again sixth period and do this 5 times. So if you hear a repeat of this, sorry, but hey, here it goes. So what have we been working on? We've been working on the quadratic formula. Yesterday we did a few of these problems. Today we're going to kind of take it a little bit further as far as estimated solutions and actual solutions. We begin by identifying A, B, and C. This is just, again, something that I've done and had to do when I got back into math after high school and said, why do I keep making so many mistakes? How can I cut down on making mistakes? Well, the first thing is to identify A, B, and C. So A would be 1, B would be -5, and C would be -5. And I believe this is page 16. 18. Right? 18, thank you, 18. Okay? Well, what do I do next? What I do next is I write out the formula. So x minus, using parentheses, not actually putting values in yet, but using the parentheses. So minus parentheses, because that's where B goes, plus or minus the square root of parentheses squared, again where B goes, minus 4 times 2 sets of parentheses, because it's minus 4 times A times C, all divided by 2 times A. And then I'm simply going to input those values. And again, I use parentheses, again, because in my experience, it cuts down on my mistakes. So minus 5, plus or minus the square root of minus 5 squared, minus 4 times A, which is 1, C, which is -5, divided by 2 times A, which is 1. And now I can go ahead and manipulate this. Most of us, and again, we look at this as a monstrosity, most of us actually will get to the actual solutions. Okay, we don't have a problem with that. X is going to be equal to a negative times a negative, which is positive, so plus 5, plus or minus the square root of 25 squared. And again, as I stated yesterday, and I will state all the time when we do quadratic functions, is it going to be 25 plus or 25 minus? I just ask myself that question. I've done it over and over and over again, and I ask myself, well, how do I determine that? A negative times a positive is negative, a negative times a negative is positive, so it's 25 plus. All I'm doing is trying to cut down on my mistakes. 4 times 1 times 5 is 20. All divided by 2 times 1, which is 2. And then I can simplify what's underneath the radical. 25 and 20 is going to give me x equals 5 plus or minus the square root of 45 divided by 2. These are your actual solutions. Okay? Or exact, as you will. These are your exact solutions. Right? Now, why is it exact? Well, the square root of 45 is not a perfect square. If you use your calculator, and I suggest that you in class right now do that, if you're watching this at home, grab your calculator, find the square root of 45 on your calculator. It will be a number followed by a lot of decimal places. Not just 1 or 2 decimal places, but a lot of decimal places. If we were to plug this actual answer into your calculator, it would use a lot of those decimal places to come up with your answers. That is why this is my actual solution. Okay? So these are your actual solutions. Your estimated solutions are going to be where you're going to take the square root of 45 and you're going to approximate it. Well, the square root of 49 is 7, so the square root of 45 is going to be 6.7, 6.8. That's been the debate the last few classes we've had. Some people said 6.7, some people say 6.8. Again, it's an estimated solution at this point. So now is where I'm going to take that 45 and replace it with my 6.8. So I want to estimate what my solutions are. So one is 6 plus 6.8 divided by 2. Sorry, 2 not 4. And the other one, this is why I put the or, is 5 minus 6.8 divided by 2. So I get 5 plus 6.8, which again I'm just using estimation in my head here, is going to be 11.8 or close to 12. So half of 12 is 6. So this is going to be approximately 5 point, what do we get? If we do the work, what do we get, class? Are we having issues with our calculator there? Remember, on your calculator, you cannot say 5 plus 6.8 and divide that by 2 and get your answer. You cannot do that. those of you at home, if you're watching this, you can't do that. Why? Because order of operations, the calculator is going to take half of 6.8 first and then add 5. You can't do that. So what I have to do is put parentheses around 5 plus 6.8. But who wants to do that on the calculator? You can do that on this particular calculator, but let's keep it simple. What I want to do is I want to do 5 plus 6.8 and hit the equal sign. And then I'm going to get a number. And then I'm going to take that number and I'm going to divide that number by 2 and hit the equal sign again. And that's going to give me my answer of 5 point something. What do we get? 5.9. Okay, so 5.8, 5.9, around in there somewhere would be a reasonable answer. We need to do the same thing with the other one, only now we're saying 5 minus 6.8. So now it's going to be a negative answer. Why? Because there's more negatives in the numerator than there is positive. So a negative divided by a positive is negative, and that's going to be 0 point something. What do we get there? 0.9. All right? Respectable. We can deal with that. Good job. All right? So there's number 6. Okay? Any questions on number 6? Again, the focus here, other than yesterday, was we have our actual solutions and we have estimated solutions. That's the difference. So our actual is going to be with the radical. Our estimated, according to the book, is going to be our decimals. All right, so let's try number 8. Again, we want to identify A, B, and C. And I'm telling you, if you do this, you're going to cut down on mistakes. It doesn't mean you're not going to make them. I had a student last period make a mistake, even wrote down A, B, and C. Hey, it happens. You know what? We're not perfect. Okay? I make mistakes too. So x is going to be equal to minus, and again, we put the parentheses. We put the radical, parentheses squared, minus 4 times 2 sets of parentheses, all divided by 2a. Yeah, I'm going fast. I'm going to pause and let you catch up. As you do something, as you get out in the real world and do a job more and more and more, you'll get faster at it. Right? It's okay. A lot of it's repetition. But a lot of life lessons like what math teaches is just, hey, show our work so we can figure out where we make those mistakes. We want to cut down on those. We want to cut down on those mistakes. We have some larger numbers here, which just means I'm probably going to have a larger answer. That's okay. So minus b, or b squared, 4 times a, which is 2, times c, which is 5, 2 times 2. And then we go ahead and we manipulate. Minus 8 plus or minus the square root of 64. And again, I pause, just like I said I would every time. Is it going to be 64 minus or 64 plus? A negative times a positive is negative. A positive times a negative is negative. So it's 64 minus. I don't have to decide that anymore. Okay? It's the little things. 4 times 2 is 8. 8 times 5 is 40. All divided by 2 times 2, which is 4. And I can get ready for my next step, which is simplifying the radical. So minus 8 plus or minus 64 minus 40 should be 24, if I recall correctly. And there is my exact solutions. Again, with your radical, that is your exact solutions. Why? Because if we put it into a calculator, it's going to take all those decimal places. Okay? It's going to take all those decimal places. We're not going to do that. When we estimate, we don't do that. So x is going to be equal to, well, the square root of 24, hey, the square root of 25 is 5. So the square root of 24, I'm not even going to use my calculator. I'm going to say that is 4.9. So x is equal to minus 8 plus 4.9 divided by 4, or minus 8 minus 4.9 divided by 4. Again, I'm just estimating. These are estimated solutions. I don't need to be exact. Okay? If you're working on airplanes or rockets, I probably want to be exact. Okay? But we're not doing that. Minus 8 plus 4.9. That's going to be a negative answer because there's more negatives than positives in the numerator. And then I got to divide by 4. What do we get? Anybody do that yet? 0.775. Okay? So I would say either negative 0.7 or 0.8. Again, it's an approximate answer. Minus 8 minus 4.9 is minus 12.9. That's going to be negative 3 point something because That's going to get me close. 12.9 is close to 13. Okay, 4th to 13. What do we get there? 3.2. Okay, again, approximate solutions. Okay, anybody have any questions on that? It should be pretty explanatory. You doing okay with this stuff? I know you've gone yesterday. Yeah, it shouldn't be too bad. Now that you've tried using the quadratic formula, here are a few questions to consider. Why do the solutions of a quadratic formula contain a plus or minus? Where is the plus or minus? The plus or minus is in front of the radical. Okay? Why? Because radicals have two possible answers. A simple example of that is here. The square root of 4 is equivalent to 2, right? But if I say 2 times 2, I get 4. Let's do the opposite of that. The opposite of square rooting is squaring. So 2 squared is equal to 4. But negative 2 squared is also positive 4. So whenever we take the square root of a number, we're actually taking the square root of a positive solution and a negative solution. That's where that comes from. So if I would have shown you how to manipulate, and we actually did a few of these the other day, when we took the square root of both sides, solving by inverse operations, this led to plus or minus the square root of a number. Is it possible to only have one solution in a quadratic function? The answer to this is yes. It is possible. Why is it possible? It said what would that mean about the associated function? The associated function is the quadratic formula. So what would it mean using the quadratic formula? What would it mean if we only have one solution? It means the radical goes away. It means the radical goes away. Well, what do you mean? Let me give you an example. Okay? I'm going to give you an example over here on the left side of your paper. Using the answer we got up there, minus 8 plus or minus, but instead of it being the square root of 24, it's going to be the square root of 0 divided by 4. Am I going too fast? Again, this is just an example. What happens to the square root of 0? Well, what is the square root of 0? It's 0, right? So if the square root of 0 goes away, the plus and minus goes away, doesn't it? So now I just have negative 8 divided by 4, which is negative 2. There's one answer. That's possible. It doesn't happen a lot, but it's possible. What does it mean if the number inside the root or solution turns out to be negative? I'm going to use the same scenario here, but minus 8 plus or minus, and I'm going to go back to the 24, but I'm going to make it a negative 24 over 4. And we're going to question that, because that's what it's asking. What does it mean? What does it mean? It means the solution is complex. That's what it means. It doesn't mean there's no solution. It means the solution is complex. And here's where we begin to learn about complex solutions. What do you mean by complex, Mr. Wilson? What do you mean? Well, as stated last semester, we have 3 possible scenarios for graphs of quadratic functions. Write this down, don't write this down, I don't care. I would kind of prefer you don't, because I would prefer you listen to what I'm saying. Okay? I'd prefer that. What is one possible solution? Well, one possible solution is what we've been seeing a majority of the time, is where the quadratic line crosses the x-axis twice. Here is a situation where we have 2 solutions. We also have another scenario where that quadratic function comes down, hits the x-axis, and goes back up, and only touches it. That is a situation where we have 1 solution. Well, when we get to complex solutions, we have a situation where we have a parabola, but that parabola never touches the x-axis. And that is where we have 0 solutions. Well, what do you mean? We have 0 solutions, but we still have a graph. Yeah, we do. That just means the graph is what we call complex. That's how they labeled it as complex. And we'll see that here in the next question. Everybody okay with this so far? Okay. So now we move on to the next one. I was going to have you do this by yourself, but I'm not. I'm going to have you do the last one by yourself. So let's go here. A, B, and C. This will be short because we're only going to, I'll just tell you right now, you're going to get a negative radical, and we're only going to go to exact solutions. That's it. We're going to stop there. I am going to front load a little bit with some of the other stuff and not have you write it down. A is 2, B is 6, and C is 5. So you get x squared minus 6 plus or minus the square root of 6 squared minus 4 times A times C, which A is 2, C is 5, all divided by 2 times A, which is 2. And again, if you've been paying attention the last couple of days, this monstrosity of a thing called the quadratic formula actually simplifies fairly quickly. Again, why do I put the parentheses? For me, it cuts down on the mistakes. So minus a positive 6 is negative 6, plus or minus 6 squared, which is 36. Is it 36 plus or 36 minus? A negative times a positive is a negative. So it's 36 minus. 4 times 2 is 8. 8 times 5 is 40. All divided by 2 times 2, which is 4. The next step is to simplify the radical, which is what we've been doing. It's important that you say 36 minus 40, not 36 plus 40. Again, this is why when I square the first term or that b value, I establish what the sign is. I see so many students, they want to say 36 plus 40, and that's not true. 36 minus 40 ends up getting you plus or minus the square root of negative 4 divided by 4. Here are my exact solutions. Notice the negative radical. Okay, so what does this mean? Well, based on the last answer to the last question, or the answer to the last question that we discussed, this means that my graph doesn't cross the x-axis. You'd be absolutely correct. It would be a graph that would look like this. Something like this. That's what it would look like. There's no solution. Why? Because the radical is negative. We haven't discussed this a lot, but you cannot take the square root of a negative number. You can't do it. Well, actually you sort of can. I'm not really taking the square root of a negative number, but I'm adjusting it so that the square root is not negative. Right? Here's where I want you to stop and watch. I don't want you to write this down. I want you to stop and watch. I'd rather you process this, because even if you write it down and you process it, you're still not going to retain it, because we've seen this once. So here's how they handle this. I'm going to take this negative radical and I'm going to manipulate it a little bit. I'm going to manipulate it by making the radical positive. If I do that, the negative had to go somewhere. Where did the negative go? Well, I'm going to change it by multiplying it by the square root of negative 1. All I did was I moved the negative. The negative is still a radical, but I got rid of the 4. I associated it in a sense and got rid of the 4 and made it positive. So now I can take the square root of a number. Well, all of this is still divided by 4. So minus 6 plus or minus. Now, since the square root of 4 is positive, I can find the square root of that. The square root of 4 is 2. But what about the square root of negative 1? This is where in math they change that. If it's the square root of negative 1 all by its lonesome, the square root of negative 1, they assign it a letter, and that becomes the letter I for imaginary. That's what imaginary begins with, is an I. So they assign it a little italicized I. This would be almost my answer. Well, what do you mean almost? Minus 6 over 4 I can reduce, and 2 over 4 I can reduce. So this becomes minus 3 plus or minus I over 2. and where you get the minus 3/2 is your line of symmetry. Remember I said we do not have an x-intercept? Again, I don't expect you to write this down, okay? I want you to follow. Here's my graph, and this is where imaginary or complex solutions, this is how you graph them. Remember how we normally graph and we have an x-axis and we have a y-axis? Well, since it becomes complex, it's no longer x and y, it's what we call real and what we call imaginary. Okay? Okay? Real and imaginary. I'm going to go out the real number, which is -1.5. That is my axis of symmetry. Remember, there's always a number in front of a variable. So right here, there would be a 1. This would be 1i. I would go up 1/2. So, out -3/2, up 1/2. Here is my parabola, something similar to that. And that's what the graph of that would look like. It has no x-intercept. Okay? Because the negative. We'll dive into that more, right? We're not going to dive into it a whole lot. Okay? This is some complex stuff, hence complex solutions. But that's what we're going to dive into. All right, what I want you to do for here, I want you to find your real solutions and your estimated solutions, okay? Or your actual solutions and your estimated ones. So give me an answer with the radical, give me some answers with some decimals, identify A, B, and C, and we'll come back in a few minutes and we'll see how you do. All right, so try this one on your own. For those of you at home, good luck.